Start. Hello my dear friends and my dear students, myself Rajendra Mahanti. I am going to teach you about your experiment in impulse turbine. The aim of the experiment is the performance test in impulse turbine and to find out the efficiency of the turbine. So first of all, going through the experiment, before we will be started, what is turbine and how it works and where it is used. So first of all, what is turbine? The turbine is a prime mover which will convert hydraulic energy into mechanical energy. That is called turbine. Then classification of turbine is considered different types. What you are considering here through the inlet of the turbine. What is the amount of energy is available at the inlet of the turbine? There are two types. What is number one is an impulse turbine and one is a reaction turbine. So what is impulse turbine? The impulse turbine means what? Where at the inlet the kinetic energy is available, then that is turbine is called as impulse turbine. But in a reaction turbine, the kinetic energy as well as pressure energy is available, then the turbine is called as inlet, that is a reaction turbine. So you have to study about impulse turbine here. The turbine, where the turbine used first of all. Turbines are different types, that is steam turbines, gas turbines and here hydraulic turbines. So basically we are studying about hydraulic turbines. The hydraulic turbines are used for a reservoirs, where in a dams and reservoirs. So here it required high head. In a turbine section, there are according to the head, there are different types of there, medium head, low head and high head. But using impulse turbine, so that is a high head turbine, we required a high head here. From the reservoir of dam, go through the, if you watch the reservoir of dam, there is a height available is here. From the surface to the height is more, it will be go through the penstock and go through the nozzle, the kinetic energy should be high because of the height. But we are considering here impulse turbine of high head, so due to this consideration here, we use pump here for getting that much of pressure here. So converting the pressure into kinetic energy here. So go through this, first of all you see the turbine test rig, that is an impulse turbine test rig is here. This is an impulse turbine test rig. Look at this, this is an impulse turbine test rig. And there is some specification are there, which will rotate here also. So first of all, there is specification given through the pump. So here needed the pump should be needed here for high pressure to go through the water flow through this pipe. So pump is a centrifugal type and high speed type. Here is a single suction wallet. Power required should be AC power is required for a 15 HP motor. There is AC power required 15 HP motor, 3-phase connection, 440 volts. And the speed of the motor is 2880 rpm. There is a 2 spring balancer uses here, and the runner diameter is here 0.226 meter. The number of bucket in a runner is here 18 numbers, and the rated speed should be 800 rpm. The speed rotation should be 800 rpm of the shaft, and the power output should be 5 HP. Means you are giving the output power is here 5 horsepower, and the flow measurement through the orifice meter. This is the specification of the test rig of an impulse turbine. So going through the test rig, first of all go to the connection, 3-phase connection. Here is your motor is there, 3-phase motor is there, which will be connected through the centrifugal pump. Through this input power, there is a centrifugal pump should be rotated and will be suck the water through the tank. This is your tank, this is your centrifugal pump is there. So going through the centrifugal pump, the water should be go through the pipe. So there is a flange is there between the pipe, which will be give the losses here. Means if you go through a pipe, there should be losses there. In any pipe you can measure that there is some losses are occur in a energy level. So here is the inlet of the centrifugal pump pipe. Here is a flange outlet pipe. So here is the inlet pipe. There is a pressure gauge is there, which will be show that what amount of pressure should be go through the pipe. It will be co-inlet pipe. This is outlet pressure gauge, which will be show the pipe after going through the flange. So this is your flange pipe. But you are using hydrostatic power plant here, hydrostatic turbine. So you needed penstock here, but here there is not that much of height is not given here. So we are using for test rig. So it will go through the pipe. This is a pipe, is one type of penstock here. This is your penstock, and also you can consider this is pipe. Okay. So going through this pipe, water go through this driver. There is a orifice meter is there, which is 50 mm. The die is here 50 mm. Given is here 50 mm. The office meter dia is here 50 mm. Here is written is there 50 mm, which will be controlled through this driver. So what amount of water should be go? Should be what is the pressure of the water? Through pressure gauge you can measure it. And this is your nozzle section. This is a fixed type nozzle. There is a sphere gauge there which is fixed here. So this is fixed type. In another turbines you can use this type of drive through positioning the nozzle. So you have to position the nozzle. There is a driver there, but it is a fixed type. So you are only fixed. There is a line of water should be go through the fixed line and fixed position. And this is your casing. This is your casing where the water should be circulate here. This is your Pelton wheel turbine. Look at here. This is a Pelton wheel turbine. This is also called as high head and tangential turbine. Why it is tangential? Because tangential flow should be occur through the nozzle. This is your nozzle section which is fixed here. In other turbines or test rigs there is a movable there is there, but here is a fixed nozzle where you are considering here. So this is fixed type of nozzle and the flow should be controlled through this orifice meter. What amount of flow will occur through this orifice meter, you can control the flow, and nozzle section should be fixed here. So here is your buckets are there. Coming close. So here is your buckets are there. The types of buckets is 18 buckets are there. Let's you count it. It will be 18. And the inside the runner, that is called as runner. The runner, the bucket will be fixed here. Then after it will be a shaft which will be connect through the outer, which will generate the power. It is a hydraulic energy which will convert into through shaft to transfer the mechanical energy through this. So this is your pulley. This is your belt drive. This is a belt drive pulley where the true spring balance is added here, which will give the load here. Automatic of load, the fluctuation should be given there. And this is your pulley section. After rotation, there is a create some heat energy. So to cooling this pulley uses some coolant, some water is there through this, which will be used to coolant here. And this is your tank where the water should be supplied. So this is your empty tank, but experiment time we can use this full tank. Okay. So this is the water. You can full or 3/4 of the tank. You can use this for a turbine experiment. So this is all about your turbine. So this is the demonstration about your all turbine, impulse turbine, and the Pelton wheel turbine. And this is your only demonstration is there in this video. Next video we can edit the experiment of the impulse turbine or Pelton wheel turbine.